Yeah, I want to ask kind of, or start a little bit with a question. How many of you know what the solver is or have run one? Stuff like this, okay. It's a little bit bright here, can't see it. Okay. Yeah, thank you. That's at least a bunch, I think. Yeah, so solvers are off-chain programs or actually off-chain agents that are actually searching for the best solution or execution for an order or an intent in a decentralized protocol. As such, they are part of the order or trade supply chain, as you can see here. So there might, for example, be a DEX, and that DEX delegates finding solutions to a set of solvers, auctions that off basically, and solvers then win an auction, execute those solutions, and yeah, then they follow downstream the transaction pipeline. What's important here is that basically solvers were introduced as a means to yeah, build economic trust with users once like actually the whole landscape became so complex that it wasn't easy for a user to figure out which protocol to use, where to swap, or where to trade. Then actually in order to build economic trust with users, protocols started to introduce solver competition and as a means to build an efficient market. Yeah. Yeah. That hurt. Okay, yeah, in general, the solving process looks like you can see here. It's a little bit different depending on what you solve for. So for a swap or for a cross-chain order, for example, it looks a little bit different, but it's worth to look at the individual steps. Yeah, it's 5 of them, like the boxes here. The first one is actually sourcing liquidity. That means most of the orders that get solved today are actually related to moving funds or like swapping funds. That means there's usually a need for liquidity that needs to be involved. And sourcing liquidity means as a solver, I have to understand which liquidity sources do I have available. This might be own inventory, this might be RFQs and private liquidity, that might be AMM, public on-chain liquidity that's to be used. And then I have in the second step to understand how can I route through this liquidity. That means depending on the size of the trade or even like the tokens involved, I might want to choose certain venues for the trade, maybe a combination of own inventory and on-chain liquidity. Or a route swapping through intermediate tokens and stuff like this. After I found the optimal route, basically, I have to do some risk management. That means in usually, for example, something like limit order, I have a potential upside that is related to actually executing that order, and I have to understand, yeah, is it actually worth to take that risk for that potential upside? That means I have to include considerations like market volatility risk when I'm swapping tokens, or even other risks like finality risk or reorg risk in the cross-chain case. Then assumed I won the auction as a solver, I will execute on chain. And then also there's a step related to settlement. That means the step where actually the funds change between the traders. Yeah, you can, the 2 arrows here basically indicate 2 different swap types. One, the first example is basically yeah, something like cow swap, where a solver uses only dedicated AMM liquidity. That means no inventory, no private liquidity to actually execute trades. Then you can see here with the dots indicated basically, yeah, that it has to kind of source liquidity, complex task in this situation because there's a lot of liquidity sources changing all the time. Route optimization also very difficult, or at least like quite complex to understand where to route liquidity through and through how many hops and venues. Risk management the same, so a lot of volatility risk, especially when it's related to long tail assets and stuff like this. And then settlement and execution usually in that case happen in the same step. In the cross-chain case, it's a little bit different, a little bit simpler. In the cross-chain case, there's always a need for dedicated liquidity, so there is not like corresponding thing like an AMM swap, because I need to front the liquidity always on a destination chain. That means I have to have it available. There is no such thing like route optimization because I always have dedicated inventory usually, so I don't need to route through different on-chain liquidity sources. And settlement, that's also an important step because it will come up later. Settlement in the cross-chain case is actually delayed. That means like I usually get repaid by the protocol a little bit later after I've fronted the liquidity. And this settlement delay is also includes certain risks depending on the tokens I've used, as well as also certain set some limits on the capital utilization basically. Yeah, here's a short history of solver-based designs. I think TLDR is like solver-based designs are winning. A lot of protocols use them already. A lot of announcements happened recently and will happen in the future. in terms of new protocols using those designs. Okay, based on that, we want to now look a little bit more into what's the direction of like, hey, we understand now what a solver is, and then a little bit about the history. We want to look a little bit about what's solving like in terms of operation. We did an estimate here based on our own experience as well as, speaking to some teams. And what we can see usually is that, operating a solver in production, that means, with the ambition to kind of become, I would say, at least the top 10 or top five in that protocol in terms of solving, requires a ballpark number of 13 to 26K monthly in USD in operational costs. And that, we will use that a little bit later in the numbers to kind of compare that again to make up profitability numbers for solvers. But that's what you can, assume as costs, and it's a mixture of infrastructure and staff costs, obviously. All right, we want to look at two examples. We solve in them. That's cow on the one side, across on the other side. Cow is a DEX aggregation protocol. That means usually swaps are being solved there a little bit like in this first example, exactly, the AMM swap example I used. Across is a cross-chain protocol. That means today, mostly bridging. That means bringing, for example, USDC from Ethereum to Arbitrum. What's interesting here is the mode of competition. For example, cow has a quite complex auction model, second price, batched, off-chain, sealed bids, or some of the aspects that it has. Across is a quite pragmatic protocol, I would say. It's first come, first serve. So whoever fills the limit order first actually has won the order, no matter if the second best would actually have a better price or whatever. They are also a little bit different in terms of market entry for solvers. So cow is actually permissioned, so it has a quite high bond, I think at the moment of 750K or something like this, but it's quite a substantial bond that you have to provide as a solver to actually be able to participate in a cross. It's actually permissionless, so anybody can participate. That's also then a little bit mapped in the numbers. So we did here numbers across, I think, April, or from January, including April of 25, and we saw 21 solvers in cow actively solving orders, while 78 in a cross due to the permissionless nature. That makes sense. One thing I forgot is basically the revenue side of things. So cow protocol has a protocol fee. You can see that here it's basically the 2,000 ETH that have been collected, and 30% of the overall collected revenue has been distributed to solvers. Across has no protocol fee. That means all the revenue being collected is distributed to solvers, and that has been in the period mentioned 1.25 million USD. Okay. With that, we want to now look a little bit more into the two protocols themselves. We want to maybe start with cow. Nadiem?
Yeah, sure. So, and just one thing, like I think it's interesting to keep that in mind. You saw the numbers, 21 on cow, 78 on a cross, and Alex described what the solvers are doing. And so you have to imagine that during each auction period or like solving period, 21 solvers are doing the more or less exact same shit. And 78 solvers are doing exactly the same stuff, like routing through the liquidity, trying to build some routes. And I mean, it's not easy, of course, to set it up, but it's pretty brain dead to do this. And it's somehow funny to imagine that like there is this very stupid task of doing this, and like it's run by hundreds of different solvers at the same time, again and again, and all trying to build their own versions of this. But let's now look into the numbers. So this is basically the trading volume that we had in January to April. These Greek names should mask the original solvers. I didn't want to reveal any solvers here, but you can see most of the trading volume is done by a solver called Talos. And then there's the errors and others, and they are doing okay, and then it pretty much, it quickly goes to nothing. So like it's a very steep curve. And in terms of rewards, I mean, Talos is capturing almost 50% of all the rewards that can be captured. And now it's interesting to compare this to how much you actually have to work for doing this, and how much you have to pay to get this reward. And we have this this plot here. It's a bit complicated at first, but I will describe it. So what you see on the x-axis is the ideal reward that a cow solver could have captured if the solver would have managed to successfully settle the auction that the solver has won. Because it can happen, you win an auction because of your proposal, but then you lose. And you basically fail to settle. And then there's the reward capture ratio, which tells you how much you captured of this ideal reward. So, I mean, if you are somewhere around 0, basically you lose a lot. If you are around 1, you win most of your rewards. And what you see, this green line, this green scraped lines, this is the survival zone. So basically we plotted the 2 lines that correspond to 16K a month and 26K a month. So this is how much you need to have to survive. So with an ideal reward of 150, you need to make roughly, you have to have a capture rate of roughly 20%. If you have a very lean solver. And the interesting thing is now, if you would start solving, very likely you would fall somewhere into this gray cloud, somewhere in the middle probably. And you would be wondering, so how would I get into the top zone of being profitable? And then you would realize, okay, I have to increase the number of auctions that I win. So you go for more. This is what basically Eros and Ares were doing, the orange ones. But of course, the more you win, the more auction you capture, the more risk you have that you will fail. And this is why these 2 guys have a pretty high capture rate. And now is the question, how do the olive green ones and the apple green one manage to be so successful? And the answer, I mean, we'll come to this in a bit later, is they have liquidity access that the others don't have. I mean, because the gray ones, they are all running the same shit. They're routing through all the sources, they're trying to combine the routes, maybe they miss something, maybe there are some mistakes in the algorithms, okay, there's some spread. But what really moves you forward is the private liquidity access that you have. And you can clearly see, I mean, Talos, they have a very high reward capture rate, even though they have a massive volume. And if you look at it, I mean, the amount that Talos is winning would probably last for 10 other solvers, but it's like distributed in a way that it's just going to one solver.
Yeah, and we can do that also now for across, where actually, surprisingly, it doesn't look so much different. So there's also one solver named Nessus here that is basically dominating everything with 50 to 60% depending revenue versus volume. There's also here, I mean, if you recall, there were 78 solvers in total, so only 10 of them make a little bit more than 1%. So also here there's a high rate of solvers that actually participate somehow, but don't really have an impact. The interesting thing here also in the across case is that the top solver Nessus is actually operated by the team themselves. When we compare here, and Nadiem already explained how the graph works, so the same here, it looks a little bit different because we have here a different scaling, but the survival band is also like in green. What you can see here, we have actually 2 solvers that are apple green, that means that are more or less profitable. We have 4 solvers that are like, how did you call that other green?
Olive green.
Olive green. We have 4 solvers that are olive green, that more or less in the survival zone. And the rest, and recall, these were 78 in total. Some of them we didn't even plot, but they are more or less meaningless in the sense of like impact on the solving here. What you can also see here in terms of size of the dot is actually the private inventory they solve with. As said, like in the cross, as you need to front liquidity, there is no way to solve with only on-chain or AMM liquidity. You need to have private inventory. As you can see, biggest solver solves with roughly 11 million, I think, in private liquidity, and the second one here with around 4 to 5 million. I think what also you can see here is this solver that is Nessus that's run by the protocol themselves doesn't really compete. It's meant more like to be a quality of service type solver that only picks the orders when nobody else picks them. So now we can argue why does nobody pick the other orders that are usually very large orders, but it's very likely that all this also draws back to actually the amount of inventory or liquidity that's available. That means if you want to participate, and I think most of the solvers in the green band work with around 300 to 400K of liquidity. If you want to go in the profitability zone, you need at least 7-digit amount of private liquidity available in USD, else you actually can't really meaningfully compete. And if you recall also the complete revenue that has been distributed across for the first 4 months is a little bit more than 1 million, so it's also not a super high sum. Okay, we have to speed up a little bit. I think, to sum it up, we have kind of winner takes all dynamics here. That means like there's very little solvers that actually own the complete market basically and dominate. Most solvers aren't profitable, no surprise. And then liquidity alpha, what we mentioned, especially private liquidity due to its special risk profile, dominate and actually give solvers a unique advantage and edge. The more interesting piece is now a little bit like how can we actually improve on the competition and create more efficient markets based on those conclusions. And we thought we start a little bit with like some analogies.
Yeah, I'd quickly go through this. I mean, I originally come from traditional banking, and I mean the funny thing is like for most of these problems, I mean these occurred before in private finance, and like there is a complex network of regulations and systems to make sure that these things don't happen. I mean, of course, they still happen, but I mean, there's antitrust and contestability regulation. There is structural separation that tries to make sure that certain businesses cannot merge. So you have to, for example, you cannot. I mean, after the financial crisis, retail user deposits and proprietary trading are separated. So all these things came into place. There are transparency mandates about the quotes. They are audited. Then there are some entry rules for entering as a market maker at an exchange. Then there's latency control. I mean, there was a wave when high-frequency traders took over because they had the advantage of like being faster in the order book, and then some delays were introduced. So there is a lot of things. I mean, I'm a bit faster than I wanted to, but there are a lot of things that are here already existing. I'm not saying that we can replicate them, but I'm just saying there is a lot in traditional finance to prevent something that happens in our space right now, and we don't have much. We have blockchain and we have competition right now.
Yeah, and the second example to that, I also like to take some, would say, inspiration from, or maybe some learnings from, is also block production. So when you look at this here and look at some of the alpha sources or like centralizing forces, then there's kind of some similarities both in terms of private order flow, simulation, and infra between block production and actually the solver-based networks and centralization we see here. So also, efforts like proposer builder separation or other types of measures to counter builder centralization might be worth looking into for getting some inspiration. Okay, so now let's talk a little bit about some pillars of like how actually an improved solving system could look like.
Yeah, so I mean, like I think we have to like think about some design principles, and we are giving some of the ideas here. So one, I think, is we need to be much more strict when it comes to role and function separation when we are talking about solvers. And we have to think about how do we want to reward? Do we want to give a performance-based reward for all of our tasks? Then we will have a race to the bottom for most of the stack. Maybe we want to have some services that are more as an SLA agreement. Then why don't we treat them like this? Part of the alpha that we have mentioned is the liquidity index. I told you that 100 solvers are every time scraping the blockchain. Does it make sense? Shouldn't we have like one liquidity index that would be updated by the liquidity sources themselves, by more like a push service? And then there is the private liquidity, which is one of the biggest factors. I mean, of course, we can allow private liquidity to just enter our auctions, but maybe it would be smarter to have something like a funnel where private liquidity providers can provide the liquidity, but all the solvers have access to it.
Yeah, and two other measures here that could be taken is also non-competitive solver selection. Nadiem mentioned that already, that matching the basically function that something executes in the solving stack with the economic model. So non-competitive solver selection could be working together with solver performance scoring, for example, for the execution side of solving, or for even like a complete cross-chain fills, as Across is trying to introduce or introducing right now. And last but not least, here also public access to retail liquidity. So the other idea would be we could also counter private liquidity alpha with actually enabling retail liquidity or generally liquidity to be pooled and then be accessible by all solvers without restrictions. Yeah, we want to close a little bit with a little bit more far outlook.
So like one vision how we could see how it goes. I mean, right now we have like, let's say the centralized phase, we have remote solvers, we have private liquidity, we have some kind of like domination of the space, and like what we could see could happen is first step is something like a solver net, like similar to the builder net that is that is coming to existence for the building space. It could have some of the features that we mentioned during the pillars, which is like shared liquidity index, have a shared intent mempool, use T security, either for privacy but also more for a better selection of solvers. And then a later stage, I mean, it doesn't mean exclusive stage, but we could imagine a stage where, similar to your hardware wallet, you have a local T or you have a local agent running in your MetaMask or whatever wallet that is basically solving for you. Because if all the information that you need for solving, which is the liquidity sources, the routes and everything, is like standardized and like distilled in a way that is easily digestible, then this can run in a local engine. And then the user not only has the control over the keys, but also has the control over the transaction that he wants to do.
Yeah, with that we are closing, I think. Yeah, it is a collaborative effort. So if you're working on solver infrastructure, or some of the issues mentioned, yeah, please reach out. We'd love to hear from you. Thank you, guys.
Thank you. We actually do, I mean, we did run a little bit over, but we have time, I think, for 1 or 2 questions. Let me start with the first one. You can't see it yet, but I'll just read it to you. How does lower latency blocks affect solving?
I mean, it's not direct. I mean, like, I mean, you have these like discrete blocks, but it comes again when you think about liquidity sourcing on centralized exchanges. If you want to have the top quotes that you can get from a centralized exchange, and if you're the one that is the fastest, you will be able to extract this liquidity, and you will win. So this is basically one way how a high frequency access to centralized exchanges can help you to dominate.
Okay. I think we even have time for one more. For which protocols do you run solvers? Which ones are good to get started with?
Oh, that's a good question. Yeah, at the moment we are running solver for Cow across Maya and Rhinestone mainly, and some others that are in the pipeline. I think a good one to start is probably Across, because yeah, as I said, it doesn't have some of the complex liquidity sourcing or optimizations that Cow requires, for example. So it's way simpler.
Also, no penalties. Cow has penalties.
Yeah, no penalties is a good one. Yeah, so Across would be a good one to start. Also, it's permissionless, so you don't need to put a bond, which is also good.
Okay, nice. If you answer really shortly, we can go for one more. Why exactly are TEs needed in a solver net?
I mean, you need it for everything where you want to make sure that something that you don't want to fully disclose happens in a certain way. And for example, private liquidity providers might not want to basically show who they are, like where the liquidity is coming from, what is their actual